Hi, this is Mrs. Davis. I'm doing a pre-calculus, lesson 1-7, rational functions and end behavior, and this is video 2. I'm on page 2 of the notes. All right, so let's get a formal definition for a horizontal asymptote. Instead of those three little things that we always use, how do we show that mathematically? So that's what we're going to be talking about. So a horizontal asymptote, a line y equal b is 1 when the limit going to negative infinity, so the end behavior from the left going to negative infinity is a number, or the limit going to infinity of the right side is a number. Now, many times they're both a number, so you can have only the asymptote affect one side of the function. Sometimes there are two asymptotes, two horizontal, but it's infrequent and we're not talking about it yet. So let's not worry about it right now. Maybe you'll be tempted to look forward to that or look it up. All right, so it says write limit statements to describe the end behavior. So we're just going to look at what we already know. We're still doing it with our little trick. This has the degree on the top, the same as the degree on the bottom. So I know I have a horizontal asymptote at y equals 1/3, and that would be my b, okay? So from both sides, it would be 1/3. So the limit as x approaches negative infinity, f of x, is 1/3. And the limit as x approaches positive infinity of f of x is 1/3. So easy breezy. All right, now let's look at what we have here. We have the degree on the denominator is larger, so we know we have a horizontal asymptote at y equals 0. So that means the limit as x goes to negative infinity of g of x is equal to 0, and the limit going from the right of infinity of g of x is also equal to 0. All right, so let's look at this third one because it's a little different. I have the degree on the top is larger than the degree on the bottom. And so if you think about it, what's going to happen? Will it be negative as I go, if I put in a negative number, or positive? So you can look at it like if I simplify x to the 4th over x to the 3rd, I get negative 3x. Okay, if I think about that. Now, if you want to know what happens at the end, if I put a negative x in, so I'm getting a negative 100, negative 500, negative 600, it's going to be positive because of that negative 3. So that means the limit as x goes to negative infinity, or as I put larger and larger negative numbers in, h of x is positive, goes to infinity. Now, if I put a positive x in, all right, and not a negative, so I'm going from to like 500, 700, 800, it's always going to be negative. So I would have the limit as x goes to infinity of h of x is equal to negative infinity. All right, so again, let me walk through that. First, we kind of simplified. Well, we simplified just the first the leading coefficient, the leading term. Degree on the top was bigger than the degree on the bottom. So I do have a slant asymptote, right? Now, if I want to see, though, the end behavior, so I know that they're going to be infinities, okay, because they don't go to, they don't have a horizontal. So how do I figure out what they go to? So what I did for the limit as x goes to negative infinity, I pretended to put in larger and larger negative numbers into this, and a negative ends up being a positive. And so I got that it would go to positive infinity if I kept putting negative numbers in. And then if I put in positive numbers, more and more positive numbers, 500, 600, 700, it would always be negative. So that means it would be going to negative infinity if I kept putting larger positive numbers in. So that's how you do that one. All right, let's look at example D. We're just looking at the picture now, and we can see we have a horizontal asymptote at x equals 2, so we can go right into the limit as x goes to negative infinity. See, from negative infinity it goes to 2. They don't say what function this is, so we'll call it f of x is equal to 2. And the limit as x goes to infinity of f of x, positive infinity of f of x also equals 2. So as I go to infinity, y is approaching 2. All right, on this graph, I have, let's see, I have end behavior. Remember, we're talking about end behavior. So it looks like I have a horizontal asymptote at -1 that they're approaching. So the limit as x goes to negative infinity of f of x is -1. And the limit as x goes to positive infinity of f of x is also -1. And there are my horizontal asymptotes. So this is a way we can define horizontal asymptotes too, using limits. All right, so if we're going to evaluate some limits, we can look at it and say, this is really saying, what's the end behavior on the right-hand side as x goes to infinity? So we are going to do the same thing. We're just going to look at it and decide what it would be. Now, if I multiplied these two together to get my first term, I would have 2x squared, ... And here I have x squared. So I have the same degree. So I have a horizontal asymptote at y equals 2. So the limit as x goes to infinity has to approach 2. So the limit as, okay, well, let's just put 2 right here. Okay, that limit is 2. And we have a horizontal asymptote at y equals 2. All right, let's look at this next one. The degree on the top is bigger than the degree on the bottom, so it would end up being a positive 3x if I simplified it, you know, and the leading term is the one that matters because it's plus smaller terms. So we would say, okay, I have to put bigger and bigger negative numbers in this, and if I put bigger and bigger negative numbers in, I am going to have a negative number because it's like 3 times -500. 3 times -1,000 gives me more and more negative. So the limit, I can write it up here. So it's going to go to negative infinity. All right, so I don't have a horizontal asymptote. I do have it's 1 degree bigger, so I do have, if someone asks me, a slant asymptote. Okay, all right, I'll stop this video there.